Hello, dear colleagues. Today we will continue our course about medical decision support systems based on artificial intelligence. And today we will talk about processing unstructured data for the provision of medical services. For example, how to process text, images, and other signals. This model focuses on how these types are being measured and what should we do if our data is unstructured. Unlike structured data, which we looked in our previous sessions, previous lectures, this section will cover how to use clinical texts in different languages, how to describe text mining in the area of healthcare, and how to manage efficiency and quality in this process. What are negations and context detection and why they are important? Also, we will explain why identification is something different from anonymization of medical records. Also, we will talk about important properties of medical images, we will describe important properties of medical signals, and so on. Let's start with clinical texts, as they have most noticeable differences from literary language and from language used in scientific publications. And distinctive features of clinical texts are written by clinicians or other healthcare providers for physicians, and those documents, services are being provided during the services which are being carried out. And clinical texts are used to describe patients, their pathologies, their personal, social, and medical histories. And the result of the interview and procedures which were performed by medical staff. Clinical text is not intended for publication and may not be used as a full sentences in other processes. So clinical text could be used to control codes from medical records when billing. It could contain a description of what happened to the patient. It could be used for biosurveillance to detect and monitor disease outbreaks, used to improve the set of words that are used to describe diseases, and also it could be used in clinical decision-making support for automation, of course, and artificial intelligence, as we're talking in this course. And also we could use it to add codes to the patient medical records for queries and reports. And the information obtained from clinical texts depends on the patient's health status. Some diagnoses and conditions can be accurately identified by codes. In other cases, identification of patients' conditions is only possible by analyzing text in clinical notes. So, clinical text can support clinical research by facilitating the construction of study cohorts. Clinical text could be used as a part of automated procedures for discovering new knowledge and to make us able to search for texts in specific patterns. And important problems which we are facing here will be that there could be a lot of grammatical errors or spelling errors, and In some cases, words could stick together, or could be shortened, or could be abbreviated in a not common way, so it could be not readable from the first run by automation systems. They could contain short phrases, acronyms, abbreviations. Quality of sources also vary greatly, and it's very important problem when analyzing clinical text to uh, understand which part could be trusted and which we are not able to use at all. Also, there is a problem that in many cases we can state in the text something in a negative form, that, for example, patient doesn't have a certain disease, but this disease will appear in this text as a keyword. So we should be very careful when analyzing this text to be able to identify negations when something is not present. And also there are not always existing, actually there is not always able to identify a term which will describe a negative situation when something is absent. And approximately 40% of the content of the clinical text is stated as negations. So in many cases it's a major part of the text that everything is okay, and on a certain area there is no problems. So there is a related problem of context. Negative phrases are also context of the terms, and there are a lot of other different situations to describe as a context of a certain situation. This means a condition that patient previously had, or that a number of patients' family had, or it could be a clinical context, or it could be a context related to the text only, some phrases around our keywords and so on. And in our analysis, we should reveal the context of the term mentioned in the text. There are common concerns, misunderstandings, and confusion regarding security, privacy, anonymity, and the identification in clinical records. And this situation artificially increased by the burden of accessing to clinical text as a data source. So if we need to extract something from these texts, we will have to deal with these privacy issues. Text data may contain protected health information and personal information that may not be disclosed to third parties without the patient's permission. A process in place should be in place to prevent disclosure of the identification of the patient and other relative protected information. For example, data obtained from a study involving a group of people may be identified to maintain a confidentiality of study participants, and after that we'll be able to use it. When the process is applied to metadata or shared identity data, it's also called anonymization of the data. Anonymization is a more strict concept. It refers to reverse of the dataset that individual will not be able to be identified in the future, even by study organizers under any conditions. So anonymized data is impossible to be identified in the future, the exact person in the study. The identification is also included in storing identity information that could be linked to search data in a certain situation. So the identified data could be restored to its origin if it's needed in some case. There is debate in the technology community about whether data that can be relinked even by trusted parties should be considered identified. General strategies in the identification includes removal of masking of removal of this data or masking of personal data, such as full names and suppression or generalization of the identifiers used in this text. For example, birth date could be changed without any significant distortion in the data. The problem of identification is that this process is often reversible. The reverse process, when a person is identified using his anonymized data, is known as re-identification, or this data will be called re-identified data. Successful re-identification cost could be done very successfully in cases where we have a lot of data related to this patient. So in any case, it will be quite specific for a certain person. And here we have some regular strategies of identification, and they are using of private identifier, masking, and generalization of other identifiers, using of pseudonyms, and it make us able to close or cover these identifiers in data which will lead to these personal records. And next technology will be changing this data to other names, pseudonymization performed by replacing real person identifiers with temporary identifiers. This technology allows us to remove or mask all the undesirable information in this text. This method allows you to track an individual record over the time, even if the record is updated. So it's a quite important point. If you will anonymize this data, you will not be able to link this data with the next studies related to this person. But if we will change these identifiers to a temporary one, we will be able to continue the medical history tracking, and it could be very useful in many cases. But of course, it's another side of the story that it will involve, it will make it possible for re-identification of a person using a combination of specific identifiers and data records in this information set. Also, we can use K-anonymization identities, which are signs that are indirectly related to a certain persons or quasi-identifiers. And this identifier could be a replacement for a real person, and we can use these identifiers for tracking studies and so on. For example, K-anonymization replaces some of the original data in records with a new range of values, and some of them will have unchanged values. So it will be a mixture of rearranged data and our source data. And the new combination of values will prevent the identification of a person, and also it will prevent destruction of the data records. So it will be some kind of mixture of a combined dataset. Let's continue with natural language processing. It's quite a vast field of knowledge, and it was studied by artificial intelligence specialists for several decades for now, and there are huge changes in this area right now. Now we are almost able to process human language, and our systems are able to understand it. And there are several basic steps under each system using natural human language. It will be tokenization, and the goal of the stage is to discover words and determine where they belong in the sentences. So it will be calculated tokens and their order, which will be able to use to analyze by our AI systems. Content parsing, and it will involve the analysis which determine grammatical structure of each sentence, and we are able to label each part of speech, such as noun or verb. And this technology was used before we were able to implement large language models. It was quite crucial to understand the structure of these sentences. Next one is named entity recognition. Words and phrases of interest could be identified as separate entities, and our goal could be to find a certain entity in a text. And these phrases we will be able to categorize and store in our system for future endeavors. Partition detection, it's defining boundaries between different sections of a document. It's also important because different parts of document are sorted with different purposes, and we should understand in which section a certain information was listed. And right now we have a lot of tools for natural language processing, and we are able to use them to manipulate with clinical text, and they are usually used with a certain way of adaptation to for our requirements in a certain situation. And of course, right now we have large language models which are able to solve a lot of problems in the area of natural language processing, and they are aimed in huge collections, in a utilization of huge collections, corpuses of texts, which could serve us as a useful tool to analyze data created in a new clinical reports, clinical texts. And the ultimate goal of natural language processing is not to understand the context of the document, but to identify features in the text that will allow subsequent analysis to be performed that will answer the questions. And in healthcare, it's quite important for us to understand based on which conditions our system will provide its answer. In large language models, we are unable to identify these conditions. So in a classic approach for artificial intelligence and decision support systems in medicine, we are using natural language processing and named entity identification. Just as example, we could state that a certain patient was described in a medical text, and we have a diagnosis, description for this patient, and the first step will be to detect and anonymize personal information in this text, and next we will need to highlight key terms for the future analysis. So, if we are going to remove personal data, first of all, we will need to specify everything where we can find this personal data in a clinical text. And if we can do it with a certain level of certainty, we will be able to delete this information or to alternate it for our purposes for future text mining and data analysis. And after that, we'll be able to extract certain remaining parameters from this text. Next step will be to keep only those terms that are useful for later analysis. All other terms will be filtered out from this text, and next we are able to use knowledge graph, a dictionary of terms from a computer precipitation and presentation of health information to extract these features. And of course, we should stick with only useful features. Knowledge graph can also help to decide which terms are ambiguous, and these terms have several meanings, so we will be not able to use them without additional contextual identification. And one more challenge in text processing will be to find similar terms that are not in our dictionary. So we could describe the similar situation or phrases in different terms, and we'll need to have additional search to find them in this text. Previously, we described the important problem of detecting negation and context in clinical text. Specialized software packages have been developed to detect them. Many types of clinical notes have section headings, which can be helpful when processing the text. One of the simplest ways to find section headings is to find everything that appear from the beginning of the line to the first colon character. Processing of so we are starting with pre-processing of documents which contain clinical text, and there are certain steps to be done. We will have to use knowledge graph and negation context detection tools to discover important terms. As a result of preliminary processing of the clinical text, only positive statements and information are left in the text indexed. It contains references to diseases, medications, devices, and procedures. Indexes mean that we have fixed the location, for example, a line of the certain source text from which the information was taken. Positive means that negatives are omitted. Present means that personal medical history is being used. Family history is not indicated in a certain part of the text, not to be combined with the current patient information. Next step will be to answer a clinical research question. Using the knowledge graph to find synonyms for terms related to the question, use of timeline if it's necessary to help resolve ambiguous terms. Also, we are able to count these terms and their mentions in this text. We can use temporal information, aggregated even, how often it was mentioned for medicine intake, or some studies were done, and we can collate this information with other context of the patient data. We can use contextual filters to create a matrix of patient attributes and construct patient cohorts for further statistical analysis. And the use of timing information will be crucial because in many cases this information will, all the information about patient will change over time, and we're always in a certain timelines. So we had a lot of discussion regarding clinical text, and let us continue with medical images. And medical images serve several important purposes. Of course, it's a major source of diagnostic. We are using them to determine disease stages and the response of a disease to a current treatment. They could be used to plan a surgery or to carry out a surgery if we are able to gather medical images during this procedure. Medical images capture important details about anatomical structures and physiological processes. Images are large volume and they are large in volume and require human or machine interpretation to turn image elements into meaningful parameters for subsequent prediction tasks. And each individual image is a projection of an imaged object during the passage or reflection of a beam of some kind of radiation. Machine representation of an image is an array of values with at least two dimensions, where each value is a measure of signal intensity. In modern diagnostic devices, images can be three-dimensional or even four-dimensional. That is a record volume or development over time, and of course color of the object they are gathering. And this additional dimension could be interpreted in a color patterns. Also, there are several ways to categorize medical images. It could be done by method of visualization, usually depending on the type of physical energy being used. Visible light will produce photos or videos. X-rays will produce high-frequency electromagnetic radiation that is differently absorbed by bones, air, spaces, fluids, and other tissues. X-rays, computed tomography, and related imaging techniques. They are using ionizing radiation, which can cause damage to irradiated tissues depending on the radiation dose received. Ultrasound. In this technique, we are using sound waves with frequencies higher than can be perceived by a human ear. These waves propagate through the tissue and are reflected from it depending on the density of the tissue. The advantage of ultrasound is that it doesn't harm tissues. Magnetic resonance and nuclear medicine. The use of magnetic resonance, in which the magnetic properties of atomic nuclei are measured by applying short electromagnetic pulses. The density of the fabric can be calculated based on this emission of magnetic pulses. You can also find out location of specific chemical indicators. Magnetic resonance doesn't harm tissues, but it is contradicted in patients with metal implants. Another way is to categorize medical images by characteristics, structural or functional specifics. Structural images capture the spatial location and organization of anatomical structures. Functional images indicate activity or changes over time in these organs or tissues. The most common images available from data mining are radiological and magnetic resonance images. Of course, there are several stages for us to be able to work with this type of information. We need to acquire these images, we need to store and manage them in a certain way. As I told, they are in files with a huge volume, and we will need to have a certain storage facilities for them. And of course, there are issues related to devices from which they are being gathered, data formats, and metadata preservation. Digital image storage and transmission standards like DICOM, which stand for Digital Imaging and Communication in Medicine, is a widely used standard that applies to almost all imaging modalities which we were talking before. Medical images commonly are stored in image archives and communication systems, which are called PACS. They are processing and interpretation of the images. They are responsible for processing and to be able to process and create interpretation of these images, we should be able to connect these PACS systems. And traditionally, the context of a medical image is interpreted by a specialist, and the text will be written and stored in a report and electronic health record. Our modern research in the field of machine processing of medical images is able to solve the following problems: automation of routine tasks, auto-segmentation, identification of areas of interest, automation of the creation for text description of an image at the expert level. So we are able to process this image data with an automation solution based on artificial intelligence. signal created by biomedical equipment that measures some physiological parameter and converts it into electrical signal, usually voltage, and this voltage is then converted into a digital value which could be stored in computer system. And signals are important because they provide a continuous physiological state in real time. They present time series of values at regular intervals converted into digital format. The distinctive features are signals consist of measured values at regular intervals determined by the sampling rate of the sensor. Signals are typically recorded in clinical settings where continuous monitoring is important, such as the intensive care units. Signals are meaningful for wearable devices, such as devices which are able to track heart rate, oxidation, and so on. So, to be able to gather this information, we have a huge set of wearable devices. They are tools to utilize sensor technology to allow people to monitor physical activities, exercises, sleep quality, and so on. The objectives of signal research are similar to those of image research. Automatic feature detection, automatic construction of interpretations for these features in medical texts, and the most commonly available devices use proprietary algorithms to detect features and interpret their signals from these devices. What are the main problems with these data sources? We don't know how accurate the algorithms are or what features are critical to their correct interpretation. So we need to trust developers of these devices. The accuracy of consumer devices is questionable. These are risks associated with the absence of real health problems and false reporting of non-existent problems. The true value of these devices and apps for health hasn't been yet proven. And of course, we'll have a lot of privacy issues when someone will try to connect to our device and gather our personal data. So, it's all for today. Thank you very much for your attention.